The second question on our objective is a little different in the sense it's going to give us the delta H, and we're being asked to find one of the reactants or products' value. Given the following thermodynamic chemical equation, calculate the heat of formation for the reactant SO2Cl2. What it's asking us is to make this our target variable. We cannot find SO2Cl2 in the standard chart. But what we do know is what the sum of products minus reactants will give us, a negative 62 kilojoules. We will be able to look up the water, the sulfuric acid, and the HCl gas, but we would not be able to find SO2Cl2. This becomes our target variable. Let's take a moment and just start looking up these values. Liquid water, again found under the oxygen family in our standard chart. I'm finding that to be negative 285.83. Sulfuric acid you will find in the sulfur, so look through until you find the S's for sulfur. H2SO4 as a liquid, notice it's also aqueous, but as a liquid it's negative 814, and that's a 0.0. HCl, again we're going to find HCl in the Cl's, the chlorine family, which is the front of the page. HCl is, here it is. Notice HCl is aqueous or gaseous. This adjective is a gas in our problem. That has a value of negative 92.30. So here's what we know as we set up this problem. We know the entire equation is negative 62 kilojoules. The delta H for our reaction has been provided right in the equation. That will be found by taking the sum of the products minus reactant, where the reactant has our target variable. The first product is H2SO4 liquid, negative 814.0, plus. The next product is 2 units of HCl, so let's be sure to distribute a 2 when we take the negative 92.30. Here is the sum of our products minus the sum of our reactants. The reactant, the first one, is the target, X, plus, notice the coefficient in front of the water, which is a 2 units of negative 285.83. Here is the sum of our reactants. The entire equation is negative 62 kilojoules. That's set equal to the sum of the products minus reactants. Well, right here is our target variable, the heat of formation for the SO2Cl2. I'll start by simplifying what I can inside of the brackets. I'll start with the product side. Negative 814 plus 2 times negative 92.3. I'm finding negative 998.6 to be the value of the product so far. 2 times negative 285.83 simplifies the reactants to be X plus a negative 571.66. Simplifying, negative 62 equals negative 998.6 minus X minus 571.66. Just distributing that through. Here's what we have so far. If I could add 998.6 to both sides, then I can simplify and bring that side over. Bless you. So at this point, 998.6 is now gone from the product side, brought over. So positive 998.6 minus 62 gives me a value of positive 936.6. That's minus X plus 571.66. If I just distribute the negative sign through that, negative x plus 571.66. Equals, I forgot my equals right there. That looks better. We're trying to get x by itself, so let's subtract now from both sides. 571.66. And see what we have now for the value of negative x. On my calculator, I have positive 936.6 minus 571.66. 364.94 is the value of negative x, so I'll just simply flip the sign. 364.94 equals x. And there's the kilojoules, the value given to SO2 Cl2. Now I did the algebra step by step. You wouldn't need to show all that if you could do that on your calculator. Negative 364.94, the value of our target variable, the reactant SO2 Cl2.